Okay, before we get started on content today, I want to take a brief moment to address something that I've received in a couple emails from students wanting to know how should I prepare for the exam, how should I improve my performance if I'm starting to fall behind, what should I do if I'm confused about certain topics, etc. So what I'm going to write down here is how to get caught up / prepare for the exam. Okay, so I'm going to list a bunch of resources that you have. First one that's probably the most useful, come to office hours. Monday, 12 to 1, Friday, 11 to 1. These ones are MTC hours, and these ones are just in our own Blackboard. So if you're struggling, then you can come and talk to me during office hours, and I can help you figure out what you're struggling with and help you come up with a plan to get caught up or just start figuring things out. If you can't make it to my office hours, it's or by appointment. Okay, so if you have class when I have office hours, just send me an email and we'll have an email exchange that goes something like, hey, I can't come to your office hours because I have class. And I'll say, okay, what time works for you? And you say 3 p.m. on Wednesday. And I say, okay, I don't have any classes or obligations at that time, so I'll meet you in the course room. Okay, that's basically how that conversation would go. Okay, so if you can't make it to my office hours in person, or at this time that is, then you can do that. Okay, secondly, SI sessions with Erin. So if you're not in the GroupMe, you can get in the GroupMe. She reminds everybody every day about the sessions that she's holding. So that's a great way that you can get some extra help. So like I said, many people write on the exit slip, I thought this part was confusing. I want to see more examples of it. SI sessions and office hours. That's when you're going to be able to see more examples of the problems that we do in class.
I'm holding a 2-hour review session on Sunday just for the test, so it's longer. So come if you need help.
Yeah, if you didn't hear that, online people, Erin's holding a 2-hour-long session on Sunday at the usual time.
At 8, the usual time, but I'm going to double check and I'll send out an email.
Okay, so look out for an email from Erin about that. Okay, so moving into more things about like how to study, read the textbook. The textbook has some pretty useful information in it. You can skim the chapters, look for the big blue boxes. That's where you're going to see the main content. Things like formulas, things like algorithms, and that sort of thing. That's one way that you can study. Do the problems in the textbook. My exam questions are generally going to be inspired by problems that I find in the book. There's only so many problems that you can come up with about marginal profit, marginal cost, or whatever like that, you know. So odds are if you prepare with the problems that are in the book, you'll have a pretty good understanding of what's going to come on the exam. Also, the odd problems should have answers in the back of the book, so you can check your work and see if you got it right as well. Let's see, anything else? Oh yeah, go to the MTC. Well, it's online, but the link that is for the Friday office hours, you can go to that link Monday through Friday, 10 a.m. to like 3 p.m. and meet with another mathematics graduate student such as myself, and they can basically tutor you for free. So this semester, very few people have been taking advantage of the Math Tutoring Center outside of the people in our class who come to my office hours when they're in the MTC. So if you go, it's pretty likely that you're going to have basically a free graduate student tutor. You don't have to pay, and they'll help you with anything you need for the amount of time that they're going to be there, which they rotate off like every hour or something like that. So that's a really super useful resource. You can get free tutoring. Let's see, is there anything else? Okay, one thing I would say is check your homework. Repeat the problems. Which were difficult or you got wrong. So let's say I go into my homework assignment 1.3 to 1.5 and I realize that I missed 5 questions on that homework assignment and all of them were from section 1.5. That's telling me I should probably go back and watch the lecture for 1.5. Okay, if you really don't want to invest time, you can watch it on double speed. Okay, sound like a chipmunk, but that's one way to do it. Okay, I think that's basically most of the tips that I have for you guys. I would just really want to reiterate that office hours and the SI sessions, those are how you're going to get, those are going to be the best bang for your buck time-wise in terms of getting caught up / studying. So that's what I recommend. All right, that's all. Any questions? Okay, we'll do some material now. All right, so last time, there's no warm-up problem today. Last time we talked about the derivative of f at a and the instantaneous rate of change of f at a. And we said those basically mean the same thing. In fact, we said that the derivative is defined to be the instantaneous rate of change at that point. Okay, so if I say instantaneous rate of change or slope of f at t equals a, or if I say f prime of a, maybe I should talk about that. F prime of a is what I mean by this notation. So if I say f prime of a, this is what I'm talking about. Okay, that little apostrophe there means derivative. And sometimes we also drop this word instantaneous here, so I'll put parentheses around it. Sometimes we'll say rate of change of f at t equals a as well. What is delineating this from average rate of change is the fact that I say at t equals a, not something like on the interval from a to b. If I say on the interval from a to b, I'm talking about an average rate of change. If I say at a point a, I'm talking about instantaneous rate of change. Okay, so that's review from last time. And so what we're going to do now is take a look at this graph. And we're going to try to estimate the derivative of this function at these points -2 through 5. Okay, so let's go ahead and zoom in on this graph. So we'll start with -2, which I see on my x-axis is over here on the left. And I want to estimate the average rate of change at this point. That means that I want to know the slope of my function at the point of the graph whose x value is 2. It looks like it's this point, sorry, -2, -2 comma 0. Okay, I want to know the slope of my graph at that point. Okay, so I could draw a tangent line. It would look something like this. Maybe. Can I move this? Oh no, that doesn't work. See if I can move it a little bit. There we go. That looks better. Okay, so I could draw something like that and try to estimate the slope of it, right? That's what I'm trying to do. So I don't know, it looks like if I were to trace this, if I were to go over 1 and up, I don't know, maybe something like 4 is what it would look like. So rise over run, 4 over 1. The slope is going to look something like 4. Could be 5 maybe. Okay, so that's how I do that part. And I'm just going to keep doing this process all around. I'm just looking at the graph and I'm kind of guessing what I think the slope is, okay? So now I'm supposed to find the derivative at x equals -1. So I go to -1 on the x values, and I'll point out my point on the graph, which is corresponding to this x value. And I want to know the slope of the function at this point. Do we think it's going to be a larger slope than the last one, or is it going to be a smaller slope? Smaller slope. The reason that it's going to be a smaller slope is we can see we're kind of bending downwards here, right? We're bending downwards, meaning that if I were to be standing here, walking up this hill, it would initially be quite steep, right? But as I keep walking, it's getting less and less steep as I get to the top. Okay? So that's how I know my slope is gonna be smaller the further up I go. I can also see it if I just draw this tangent line here. I don't know, maybe it looks something like this. It looks more gradual. We're not going to make an exact science out of this. We're just going to guess. Maybe it's something like 2. Okay. Moving right along, we're going to do 0 now. So I go to where I see 0. I know that's the origin. I find the point on the graph which corresponds to the x value, x equals 0. That's this point right here. And I'll draw my tangent line in. Looks something like that. That looks like it could be -1 maybe. And I'm just going to speed up a little bit here and keep doing this. 1, I go to 1, and then I find my point at 1, and then it's here, and then I draw my tangent line. That looks like it's steeper, but in a negative way. So that's something like -2 maybe. Let's see. Yeah, something like -2. Okay, then at 2, that's right there. Draw my tangent line again. Something like that. Looks pretty similar. I'm going to just write -2 again. 3 at this point here. Looks like we're bottoming out a little bit. So maybe I'll go back to -1. And then 4. Maybe I'm at 1. Something like that. We're supposed to even get 5. Okay, 5. Something like that. That looks pretty extreme. It might be 4 again. Okay, so this is how we kind of estimate the rate of change. I'm definitely not making an exact science out of this. I'm just looking at it. Does it look like... What I want is for my table to, at the bare minimum, my table should correspond to the graph well enough that, you know, if my slope looks steeper, the number on my table should be a larger number. You know, if it's not quite as steep, it'll be a smaller number. If we're increasing, it should be positive. If we're decreasing, it should be negative. You know, beyond that, if you got something closer to like 5, 3, negative 1/2, you know, these sorts of numbers, you know, I think that's fine. Okay, any questions about how I went through this process of sort of guessing what I think the derivative is at these points? Really just comes down to drawing this tangent line and then using what you know about the algebra of lines to try to interpret the slope. Okay, so next step says look at the table we completed. Does f prime of x appear to be a function of x? Why or why not? Okay, what do we think? Is f prime of x a function of x? Can anybody help me answer that? Kevin?
Yes.
Kevin says yes. Can you tell me why you say yes?
Because it'll pass the vertical line test.
Ah, it'll pass the vertical line test. Now be careful here. Are we talking about the function f of x passing the vertical line test? Or are we talking about the function f prime of x passing the vertical line test?
Yes, so would it be no then?
Well, I think your answer is right, but you're not quite right on the right reason. This function on this graph here does pass the vertical line test. And it turns out if we were to graph this, it would also pass the vertical line test. The reasoning that I was kind of looking for here was we don't have repeated x values going to different y values. Okay, remember when we had these tables, when we were deciding whether or not something was a function, we said it's okay for our y values to repeat, but these x values in blue should never repeat. Or if they do, they should go to the exact same output. Okay, if we have two inputs going to two different outputs, it's not a function, which is exactly to say that it passes the vertical line test. And if we were to graph this function, which we're about to do, it will pass the vertical line test. So let's do that. So yes, there are no repeated x values in the domain. Remember, the domain was the set of inputs. So the collection of all the inputs. If we put the numbers -2, -1, 0, 1, 2, 3, 4, and 5 into a basket, the basket is what I'd be referring to when I talk about the domain, the basket full of all those numbers. Okay? All right, so we're going to plot the values of this derivative and try to make a graph of it. You guys are going to have to excuse my terrible drawing skills. Guess we better have 1, 2, 3, and 4. And we should go down by -2. It's going to be our smallest value. Okay, so we've got -2, -1, 1, 2, 3, 4, and 5. Okay, and I'll draw the graph in purple. So first step, we should be at -2, 4. Okay, I'll put a point at -2, 4. Then we should be at -1, 2. -1, 2. And we're at 0, we're at -1. At 1, we're at -2. at 2, we're at -2. At 3, we're at -1. At 4, we're at +1. And at 5, we're up at 4 again. So if I was a kid at a restaurant and this was my menu where we had some drawing stuff on the back, I would fill in the dots like this. My function would look something like that. Now that we've graphed this, we can see that indeed, just like Kevin said, it does pass the vertical line test. However, it's not necessarily true that just because this graph passes the vertical line test is not necessarily true immediately that this one will. Okay, not necessarily true. Okay. Any questions about this plot here? You'll notice that it looks kind of like, well, let me just rephrase what I mean. There is a relationship between the way this graph looks and the way this graph looks. The relationship for curvy graphs like this, which are graphs of polynomials, is we count the number of turns that we have. On this graph here, I've got one turn here and one turn here. The derivative graph is going to have one less turn. Okay? You're going to have one less turn. So that's just some intuition for you there. Are there any questions about this whole part of figuring out whether f prime is a function or computing these values? Okay, let's fill out this table now. Okay, so we have some information. On this left-hand side, we've got f is increasing on an interval. In the middle, we should have some kind of statement about the slope of f. And on the right-hand side, we should have some kind of statement about the sign of f prime, whether it's positive or negative. Okay? So if we have some function which is increasing on an interval, and the derivative is positive, what can we say about the slope of our function in that interval? Andrew? It's positive. That's right. Okay, let's do the next one. If we've got some function which the slope of it is negative, and f prime is less than 0, what do we think should go on this left-hand side? It should be some statement about whether we're increasing or not. What do we think? A beat? That's right, we're going to be decreasing. Okay, so like we said, remember when we had a slope, or when we had functions like y equals mx plus b, if we had m less than 0, that meant we were going down, right? In other words, we're decreasing. Okay, same thing works for functions, except now, instead of talking about whether m is less than 0, we're going to talk about whether or not the derivative f prime is less than 0. Okay, so this f prime is sort of generalizing the idea that we have for lines about whether they're going up or down. For lines, it's easy. We can just look at the slope m, and is it positive? Okay, we're going up. Is it negative? Okay, we're going down. The same rule is going to apply to functions that are more curvy. If we have a curvy function, The way we tell whether it's going up or down is not by looking at the value m, because there is no value m. We have to look at f prime instead. Okay? All right, how about this last one? What do we think is happening if the slope of f is equal to 0? Yasmin?
It's the f is neither increasing or decreasing.
Exactly.
The derivative will equal 0.
F is neither increasing nor decreasing, and f prime is exactly equal to 0. Okay? So it's an important distinction to make that we're only increasing if our slope or our derivative is strictly positive. Okay? Having 0 doesn't count for increasing and decreasing. Okay? For example, if I had $500 today, $500 1 year from now, you would say that my money has not increased. It also has not decreased. Stayed exactly the same. Okay. All right. So a little more general question now. We're not asked to do a table this time. We're asked to find out for which values of x is the derivative of this function equal to 0. Now remember, the derivative of the function corresponds to the slope of the tangent line. Okay? So what this question is really asking is, when is the slope of my tangent line equal to 0? If the slope of my tangent line is equal to 0, it should be going exactly horizontally like this. So let me ask you guys, what do you think? Are there any points on this graph where we think the slope of our tangent line is going to be going strictly horizontally? Dylan?
-1 and 2.
Yeah, I think -1 is a good stop. So at -1, we've got a point here, and it looks like our tangent line would just come in and just barely kiss it there and go off horizontally. And then at 2, we're going to have the same situation. Okay, so the x values are x equals -1 and x equals +2. Okay, so those are where it's 0. I'm going to modify this question. I want it to say for which intervals of x is g increasing, and which intervals of x is g decreasing on these intervals. Okay, let's start with where g is increasing. Visually on the graph, it looks like we're going down, 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 down until we hit this 0 that Dylan pointed out for us. And then we go up, 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 up until we hit this other point where the derivative was 0. And then for the rest of the time, we're going down. So I want to express this section, which I've highlighted in blue, as an interval. I'm going to say f is increasing on, and then now I need to write down an interval, and I'd like help writing it down. Can anyone help me with that?
Would it be parentheses -1, comma 2, close parentheses?
That's right. -1, comma 2, close parentheses. I like that you used parentheses, by the way. Was there specific intent behind that?
Because you can't include -1 or 2 because they're zeros and they're not increasing.
Exactly. The slope of my tangent line at -1 is equal to 0, which means that I'm not increasing or decreasing at that point. Okay? Same deal with x equals 2. I'm not increasing or decreasing. I've just reached the peak, and for that brief moment, I'm going exactly horizontally. Okay. Now, if I also want to say f is decreasing on, what should I say now? Yasmin?
Whatever I just can't really see where it starts. I think it's -4.
Mhm.
It would be to -2, but you use parentheses for around the -2.
Mm-hmm.
And then it also decreases from 2 to 4.
Or not -2. I think you meant to say -1 there.
Yeah.
And then from 2, 4. So yeah, if you want to put -4 here, I think that's a reasonable thing to put. If we had some more information about the function, we might be able to say something stronger than that. But we can't really see what's going on further to the left. It's possible that, you know, this goes up like this and then shoots down. We don't have that information, so let's not make any claims about what's going on outside of the picture. I think this is a reasonable thing to say. Okay, so that's how we say whether we're increasing or decreasing on an interval. Okay, so based on our observations in part A and B, we want to know which of the following could be a graph of G prime. Well, let's count the number of turns on this graph here. I see 1 turn, 2 turns. So the number of turns that my graph of my derivative should be 1 less than that. So it should have just 1 turn. So I think I can eliminate A as an option. Okay? I think we can eliminate A as an option. All right. Now remember, what we said in this table, I'll bring this back up. We said when f is increasing, f prime is greater than 0. And when f is decreasing, f prime is less than 0. So in part B of our problem, which we just did about increasing and decreasing, we can infer from these statements that on the interval from -1 to 2, f prime should be greater than 0, and on the intervals -4, 1, and 2, 4, we should have f prime less than 0. Between B and C, which one are we thinking? Let's have hands raised for B, if we think B is going to be our answer. Hands raised for C, if we think C is going to be our answer. All right, I think the majority of us are going with C, and I agree with the majority this time. It's going to be C. And the reason is my graph, in terms of, if I'm reading from left to right, okay, the very farthest left I am is -4 to 1. That should say -1. -4 to -1. So the very furthest left, I have f prime is less than 0. If I look at my graph here, I can see f prime is less than 0 on this interval. And then after that, I have this interval from -1 to 2, and I know that there I should have a positive function. So since my function goes above the x-axis, I know that it's positive for that part. And then lastly, I have the interval from 2 to 4 where it should be negative again. So that's how I interpreted these graphs. Are there any questions about problem number 5? Yes, Abhi.
So just in general, if you want to include two numbers, would you use a bracket, or would you not need to use a bracket for these types of problems? Would you always exclude like the peaks and the bottoms?
Well, right. This is exactly the point that I think Emma was talking about earlier. The reason that we didn't include with brackets on these guys, like, you know, if we were to put a bracket there, then what we would be saying is that at all of the points in this interval, including at -1, we have that this statement f prime greater than 0 is true. If we were to say that, we would be fibbing a little bit, because f prime is greater than 0 at every single point in this interval except for at -1. At -1, we have f prime is equal to 0. If we have something which is equal to 0, we can't say that it's equal to 0 and greater than 0. Those two things are contradicting. So that's why we used our brackets in this scenario. However, if I were to make the statement, this is really an aside, but I want to answer your question fully. If I were to make the statement f prime is greater than 0 on the interval 0, 1 with brackets like that, that would be a true statement. Because if I look at from here to here, I'm increasing at all the points in between and at the end points. So I could include those brackets there, and this would be a true statement. However, it would fail to capture the entire situation in terms of what's going on. Whereas this says I'm not increasing at -1, then I'm increasing, and 2 is exactly the point where I will no longer be increasing. Okay, so this is a more complete understanding of what's going on in the graph. Are there any other questions about intervals and when we use brackets and parentheses? I saw a lot of people on the exit slip were kind of confused about that. Okay. So this would be a true statement, but I'm not going to write that because I don't think that this is not a good thing to write because it doesn't express fully what's going on. All right. Any other questions about problem number 5? All right, great. Go on to problem number 6. Let's see. Oh yeah, 7's a bad problem anyway. So, all right. Graph of f is pictured below. We want to know when is the derivative of f equal to 0. Okay, so basically the same question from the last problem. What do we think? Anybody? Can somebody give me 1 point where it's 0? Yeah, Ryan?
0.5.
Yeah, 0.5. Our tangent line is going to be horizontal. Are there any other points? Yasmin?
I can't exactly read that number, sorry, the one, at 3.
Yes, at 3 here, I think we're going to be a 0. And it looks like there's one more. It doesn't look like it's quite at 2 exactly. It looks like maybe it's a little bit to the left of 2. We'll call this 1.8. Okay. So one thing that I want to point out about the points where the derivative is equal to 0, you'll notice they correspond to turnaround points. In other words, peaks and valleys. Okay, so if we have some graph of f, the points where f prime is equal to 0 are going to be the peaks and valleys of our graph. Okay, the mathematical language we use to describe peaks and valleys is maximums and minimums. Okay, so if I say that I have well, really the words that I would use to describe these are that this one here, I would call it a local maximum. By which I mean it is a max, but it's not the largest max on the entire interval. This one I would call the absolute maximum. Don't need to worry about that terminology right now. We're going to talk lots and lots about maximums and minimums later. Okay, so for which values of x is f prime of x equal to 0? I think we're at x equals 0.5, x equals 1.8, and x equals 3. Okay, so again, we want to describe for which values of x is f increasing and where is it decreasing. Okay. So again, in blue, I'm going to highlight the increasing parts. Looks like we're increasing until we hit this one. Then we're decreasing for a while, decreasing, decreasing. Once we hit 1.8, then we're increasing again up until here, and then we're decreasing. So in red, I'm going to do decreasing. Where is our function going down? If I was riding the roller coaster, this would be the fun part. I'm going down, going down. So the way I would write this using mathematical language is f is increasing on the intervals 0. I'm going to put a bracket here, because it does look like we're increasing at 0. 0 to 0.5. And here I'm going to put a parentheses, because I know that at x equals 0.5, I just answered in part A, at x equals 0.5, I know that f prime of x is actually equal to 0. And remember, we're only increasing if f prime is strictly larger than 0. And the other interval is going to be from 1.8 to 3, exclusive. And then I would say f is decreasing on the intervals, should be some parentheses, 0.5, comma 1.8, and 3, comma, I don't know, maybe I'll put 4. And I'll include it just for kicks. If you don't include these endpoints, 0 and 4, that's fine. Just as long as your statement is a true statement, be careful not to include anything that shouldn't be included. I think that's the more important part. Okay, so remember, this first part tells me if f is increasing, f prime should be larger than 0. The second part tells me f is decreasing, f prime should be less than 0. Okay, so now we're expected to graph this function. We're supposed to graph f prime. So I'm going to put our points in here. This one's going to be 0.5. And then I'm going to put 1.8 on here. And then I'll put 3 on here, and 4 on here. Okay, not to scale. I know I'm increasing on, what color should I use? We'll use green. I'm increasing for the first part, which means f prime is greater than 0. But once I hit 0.5, I know that f prime should be 0. So I know f prime should be 0 at this point, and this point. Before I hit 0.5, the graph should be greater than 0, so it should be above the x-axis. So here's how I'm going to draw this. It's going to go down, 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 down. Once I hit that point, now I'm decreasing. Decreasing just means that my derivative is negative. Then I go up, I hit 0, and then I go up, and I hit 3, and then I am decreasing for the rest of the time. So this is what f prime could look like. It's not a perfect drawing, but I know at least that the sign of my function is correct, by which I mean it's positive in the right places based on our analysis of the parent function f. Questions about how I drew that graph? Was that confusing for anybody? I know drawing derivative graphs is really unintuitive the first time you do it. Feel okay about it? Okay, then we're done for today. If you want to leave, you can leave. If you want to stick around and ask questions about anything, about the exam that's coming up, or about anything at all, go ahead. Yasmin, you look like you have one. Ah, yes, thank you for reminding me. On the exam, you may use your handwritten notes and the textbook. You may not use the internet, by which I mean the internet besides from your book if you have the online book. Use the internet besides book. Or any outside help from any other person. So, work individually. You can use your handwritten notes in the textbook. Everything else is not fair game. Don't post my questions to Chegg. I will find out who you are and report you. Okay, that's all.